In this video, we will look at not being aware of fences and memory barriers. Fences and memory barriers are advanced concepts. In rare circumstances, they can cause confusion. Let's see an example for this. So basically, in this example, we have two methods, test1 and test2, and we will run those methods simultaneously inside a while loop, and we will wait for each method to execute successfully. After that, we will check for the a and b. If they are equal to 0, we will print it to the screen, and for the next iteration, we will set all of them 0 so that they are reset. And notice x, y, a, and b are defined as static integers, and we mark them as volatile so that the CPU can acquire correct fences. When we speak about fence, note that many modern CPUs has ability to reorder the instructions. So if you use a fence, you can prevent the CPU to reorder those instructions. However, you will see in this case, volatile is not enough to prevent the reordering. Let's see our methods. In the first case, we are setting x equal to 1 and a equal to y. And in the test2 case, we are setting y equal to 1 and b equal to x. Assuming this line is being executed, if y is 0, then it means in test2, currently, since this line has not been executed, but we are at this line, x must be 1. Or if y is 1, and in turn this will set a to 1, that guarantees x is already set. So logically, if these two lines are executed in order, and here as well, if these two lines are executed in order, it is impossible for a and b to be 0 simultaneously. Let's see what happens when we run this application. As you see, the output is 0, 0, which shouldn't have happened. How can we fix this problem? In .NET World, there is an API that allows us to put a memory barrier. Let's put it, interlocked memory barrier, and try our example again. Notice this time the zeros came a little bit late, but still happening, because we have not introduced a memory barrier for our second function. If you put a memory barrier as well between the statements, that will effectively prevent the CPU to reorder those instructions. CPU, for performance reasons, has an ability, if two lines has no dependencies with each other, it can reorder those instructions. In this case, y and b and x has no dependency in the context of one thread, whereas x and a and y has no dependency. If we save our file and run this again, as you will see, the error is not happening anymore. Sometimes it is hard to predict if there's any other thread using the same variables or not. A much slower but guaranteed approach is to use the process-wide memory barrier. So if you delete this and put a process-wide memory barrier, in this case we are not required to be aware of that how test2 works. And this basically yields the same result and our application runs properly. In the next video, we will look at not using task in interface signatures with potential I/O.